Okay. We start in section 3B. The secant method. Secant method is only is for a single equation. Yeah. This method, single equation, not a system of equations. Only Newton's method can be extended to solve a system of equations. Yeah, secant method, bisection method, they are for a single equation. Let me plot the graph of function n. Okay, function n. A root is here, arrow. Function value and arrow is here. Suppose we have two approximation about the root. Say one is xk minus 1. The second one is k. Now let me draw a secant line by using these 2 points. Corresponding to xk, we have a point on the graph. The point is here. This is xk. Function value at xk. Yeah. And at xk minus 1, the corresponding point is xk minus 1. Function value at xk minus 1. Now, through these 2 points, draw a secant line. Yeah, draw a secant. The secant line intersects x-axis and a point. We call this point xk plus 1. A new gas on the root. Okay. Yeah. Next step, use xk plus 1 and sk. Draw a secant line. Secant line intersect x-axis. The intersection point is xk plus 2. And now, let me find a formula for sk plus 1. Write down the equation for this secant line. The slope of the secant line. Yeah. Slope of the secant line. Yeah. M means slope. The slope of the secant line by slope formula. Slope formula y2 minus y1 over x2 minus x1. So it is y2. 2 points. How about let me take this point as y2. This is y1. Then f xk minus f xk minus 1. Then over x2 minus x1. This is the slope of the secant line. Now, by point slope formula, I can write down the equation of the secant line. Y minus y1. I have 2 points available. Let me take this one. Okay, point slope formula. Let me take this one. So y minus y1. So y value at sk is equal to point slope formula. Slope. Yeah, here. Slope. F sk. F sk minus 1. Then over sk. xk minus 1. Slope times x minus x1 xk. Yeah. Hey, now move f of xk to the right side. To the right side. Then the secant line equation is y is f xk plus x minus xk. I want to determine this intersection point. So I set y to 0. Yeah, set y equals 0 to find x intersection point. Then x is yeah, x is xk minus f xk times xk minus xk minus 1 over I need to trace. Yeah. Over f xk minus f sk minus 1. Yeah. Intersection point. Now I define the intersection point as a new gas on the root. The gas is set is to sk plus 1. Okay. Set is sk plus sk. So what is k? K is 0, 1, 2, 3, and so on. This equation is called the secant method. Okay. This is the secant method or secant iteration. Okay. To start this method, initially we need 2 points. Yeah, then k cannot be 0 because k is 0, then x 0 minus 1. Okay, so k starting from 1. Okay. When k is 1, the right side we need x1, x0. So to run this method, initially we need to take 2 points, x0 and x1. Then run the method. Let me show you one example about how fast the secant method is. Yeah, actually very fast. Right. Right. Consider this function. Yeah, function. E to x minus 1.5 minus tangent inverse x. This function has a a zero. Yeah. This function, this f has a zero between a zero or a root. Same meaning. Between what? Between negative 16 and negative 12. And now I want to find the zero. The zero. Okay. Okay. Now k xk, then possibility and xk. When k is 0, I take x0 as negative 12. Right? Take that one. So, negative 16 as x1. Negative 16 as x1. Function value is negative 12 is negative 1, 2, 3, 10 to negative 1. Function value is negative 16.838, 10 to negative 2. Right, now, starting with these 2 points, use this formula, then I get x1, I get x2. Okay. X2 is negative 14.38 something. Function value 0.138, 10 to negative 2. Yeah. Then use x1, x2 in this formula to get x3. x3 negative 14.063. Function value is negative 3. Yeah. K is 3. The method starts to converge. K is 4. 14.102. And function value 0.373. 10 to negative 1. Okay. Number 5. 14.10127. Function value 0.991. 10 to negative 8. Six. 14.10126. Function value 10 to negative 12. And then next step 14.10126. Function value 0. Yeah. 7 iterations. Get the root really fast. Of course, compared to Newton's method here is derivative at xk, right? 1 over. Newton's method used tangent line. Secant's method used secant line. Tangent method applied to the same function. Faster than this, faster, okay? But slightly faster. Yeah. Yeah, actually, the example for Newton's method is about the same function. Same function. Yeah, you compare this table and the table for Newton's method, you will see Newton's method converge faster, but not much. Okay, now let me divide the convergence rate for this method. Yeah. In homework number 2, the first problem asks you to solve the sequence as convergence rate order 3. That means that you need to know solve this. Xk plus 1 minus, the sequence converge square root of R. So this. 3. When k approaches infinity, the limit exists. Okay, C. I don't know what the C is. C between 0 and infinity. So the limit converge to some number C. This is a homework number. Number 2, the first question. So this order 3. Okay, now let me find out what is the convergence rate for secant method. Actually, the process to find the convergence order very beautiful actually. All right, topic 2. Convergence rate. We list some assumptions. Assume number 1, xk, from the secant method converge to R as k approaches infinity. That's true. Second assumption, derivative at R non-zero. Derivative at R is the root non-zero. And also second derivative non-zero. The third assumption is xk plus 1 minus the root over xk minus r, okay, the power alpha. When k approaches infinity, this is approach some number x, okay, for some alpha greater than 0, greater than 1, and a greater than 0. Make some assumption. When this limit is true, the convergence rate is order R. We first assume secant method, the convergence order greater than 1, better than bisection. Bisection linear order 1. This is the very good condition. Now, next, I want to determine alpha. Okay? I want to find out what alpha is. Now, Let me introduce for the convenience of my presentation. Let me introduce error. EK. By EK, I mean SK minus R. Okay, error. Then I want to determine alpha. Then xk plus 1 minus r is equal to, of course, this is error k plus 1. Now, xk plus 1 from secant method. So let me plug in the formula. So this is a xk minus f xk. xk minus xk minus 1 over yeah, this is a secant iteration. Yeah, sk plus 1 is this. Now minus out. Minus. Okay. Three terms. Three terms. 1, 2, 3. Now I want to combine these three terms. Find common denominator. This is a xk f xk minus sk minus 1. Then over common denominator. Then minus the middle term. Yeah, middle term. And then last term. Yeah. Okay, because denominators all the same, I can combine the three terms. Then again, let me write here. Keep is assumption in mind. So I can combine xk times f xk minus f xk minus 1. Then minus f xk times xk minus xk minus 1. Then minus r f xk minus f xk minus 1. Then all divided by f xk minus f xk minus 1. I can see some cancellation. Let me see which one I can cancel. Yeah. X times f of xk. This and this can be cancelled. Okay. Yeah. Then I arrange the terms in the numerator. Then again, f xk xk minus 1 minus r xk minus 1 xk minus r. Yeah. And then divided by f sk minus f sk. And this is E k minus 1. Yeah, here, E definition for E. This is EK. EK. Yeah, definition. And now, then again, F sk EK minus 1 minus F sk minus 1 EK over F sk minus F sk minus 1. And now continue to rewrite the expression into an expression that that is easier for us to get the result. Yeah. And then I can further rewrite it as xk minus xk minus 1 over xk. Then times f xk ek minus 1 minus f xk minus 1 xk. Then over xk. Yeah. Just algebra. Yeah. A little bit tedious algebra. Say right? Cancel numerator. Cancel this denominator. Then say right? Say. Hey, now for a second fraction, I further rewrite it as f xk minus 1. And for the second one, okay, now let me xk over ek minus f sk minus 1 over ek minus 1. Yeah. Times ek minus 1 times ek. Then over. Yeah. If you multiply this back to the two terms, then you'll see they're equal. Not done yet. Let me further. First, this is equal to xk minus r plus r minus xk minus 1. So this is ek minus ek minus 1. Okay, yeah, denominator. So let me further write it. This is xk minus 1. F xk minus f xk then times f xk ek minus f xk minus 1 ek minus 1 then time over ek minus ek minus 1 then times ek minus 1 ek. What is this? This is the left side is, don't forget, EK plus 1, the left side. Okay, now from the last equation here, the last equation, we have so we have from the last equation here, EK minus 1, EK, I move it to left side. So EK plus 1 over EK minus 1 times K is XK plus XK minus 1 and over F XK minus F XK minus 1 times F XK EK minus F SK minus 1 times EK minus 1. Then over EK minus EK minus 1. T is L2. All right. Okay. Okay. Now, can I erase? Yeah. Okay. Now, I simplify right hand side by Newton expansion. First, for this part, I apply mean value theorem for derivative. Can you review mean value theorem for derivative? It says that f b minus f a is equal to derivative some point sine b minus a. Yes, where sine between a and b. Yeah. Mean value theorem for derivative. It is the theorem is on my notes. Okay, on my notes. Okay, so here, between sk minus 1, I can find a point such that this is a 1 over f derivative at the point sum. Okay, by here. Okay. Yeah, move this to the right side, move this guy to the left side. And okay. What is sine? Where sine between sk minus 1 and sk. Yeah. Yeah. This one is easy. Okay. Now, let me simplify. Okay. Now, this by Newton's expansion. F xk. Yeah. I write it as xk minus r plus r. Then it is r plus sk minus r is l ek. L is small because I assume sk converge to r. So when k is large, ek small. Now let me expand this about r. by Taylor expansion. So first term, FR. Second term, derivative over 1 factorial EK. Third term, second derivative, R 2 factorial EK squared. The next term, L term, 1 over 3 factorial F. Third derivative, evaluate at some point sine EK to 3. What is sine 1? Where? Sine 1 between what? Between R and this one. Okay? Between R and R plus E. What is R plus E? This is the extent. Yeah, go back to Taylor's expansion. This part between R and R plus E. R plus E is X. And we are sure R is a root. So this guy is here. Right. Now let me divide this equation by EK. Then I get F XK. EK is equal to R. The first term is here. So F R plus F second derivative over 2 EK plus L term sine 1 EK squared. And now I plot this here. F of SK over EK. Okay. Then here. Then times what? Times F derivative R plus F second derivative R over 2 EK. Then plus L sine 1. Then EK squared. Yeah, EK squared. This is this. This is this. Now, very similar for this. Here, just replace K by K minus 1. Okay. And of course, this is sine 1. I use sine 2. Okay. So yeah, then very similar. This is let me box this minus. Yeah, very similar. Just replace K with K minus 1. So again, F R plus F second derivative over 2 EK minus 1 plus 1 third F. Okay, now sine 2 EK minus 1 squared. Yeah. Get all divided by EK minus EK minus 1. What is sine 2? Sine 2 apart between R and XK minus 1. Sine 2. Right, now I can cancel what? What I can cancel? Yeah, cancel this. Yeah, cancel this. Here's what I can. And Okay, then this is a further. I can write this as 1/f sine. Okay, this term and this term, a factor f double pi r over 2. Yeah, this is the this and this factor r f double pi r over 2 then times ek minus ek minus 1. Don't cancel. Don't forget. Now here the remaining. This is a 1 3 factorial f triple pi sine ek squared minus 1/3 factorial f triple pi sine squared ek minus 1 squared. Okay. Then over ek minus 1. Yeah. Okay. Now, take out from the top, take out ek minus 1 squared. Then this is over ek minus 1 squared minus 1/3 factorial f triple pi sine squared. From the bottom, take ek minus 1 out. Okay, so then this becomes over minus 1. Okay, take that one out. Yeah, ek. Right? These are brackets, maybe, yeah, here, brackets. Okay, now, cancel 1 ek minus 1, cancel. Here. And now, almost done, okay? Take limit. Now take limit. Take limit. Okay. Left side is this. K approaches infinity. Ek plus 1 over ek minus 1. Ek is yeah. This is equal to this. Now okay. Sine between xk minus 1 and xk. Where k approaches infinity, both approaches out. So sine approaches out. Okay, so this is 1 over f r. Yeah. Yeah. This is between these two guys. We assume xk approaches out. So sine approaches out. Okay. Then, okay, yes. Third is constant. And sine 1. What is sine 1? Between r and xk. xk approaches R. So psi 1 approaches R. Yes. So this approaches 1 and triple R. Yeah. This is triple R. Right? How about this? Ek over ek minus 1. As k approaches infinity, this approaches 0. How to see? From the assumption. Yeah, we assume what we assume at the beginning. We assume k approaches infinity, xk plus 1 minus r over xk minus alpha. Alpha is a. What is alpha? Where alpha greater than 1, a is some number. At the beginning, we assume this. Now, what I want to do is determine alpha. So what is this? This is our actual ek plus 1 over ek alpha, right? F in absolute value is a. This is alpha. Alpha greater than 1. What is greater than 1? 1 plus some epsilon greater than 0. So from here, we get this approaches 0. Minus. How about this term? Psi 2 between sk minus 1 and r. So f triple pi r. Then over 0 minus 1. 0 minus 1. How about here? 0 times 0. Error goes. So therefore, we have the limit is f double time r f r times 1, because I know this term here. That is the. Do I have time? Oh, I don't have time. Okay, now finally I start from here. Okay, from here to obtain the value for alpha. Okay, let's see you Friday.